Hello, and welcome to Astronomy 100. In this segment, we're going to start a new portion of the semester, and we're going to talk about one of the more fundamental ideas that comes with astronomy, and that is, how do we know what we know? And in this particular section, we're going to call it the origins of understanding. The idea is that today, we know a lot of things about our universe. We know many, many things about how the workings of astronomy are, how orbits of planets occur, how the workings of black holes occur. We know of the lives and deaths of stars. We've come a long way. But it's important that you understand that there was an era when we had to figure all of this out. And many of the things that we understand today, we take for granted. Some of the more basic ideas of astronomy, we seem to mistakenly think that we've known of the answers to these questions forever. Things like, is the Earth round or is the Earth flat? Does the Earth move? Does the Earth move around the Sun? Does the Sun go around the Earth? These are all things that we have figured out today, but there was a time when we didn't know the answers to these questions, and it took a great deal of effort to be able to figure these things out. And in this section, we're going to talk a lot about the history of astronomy, and we're going to highlight various people along the way. And the subject of the history of astronomy could be a lengthy one if we wanted to make it so. But instead, what we're going to do is highlight the various people who made the important contributions to our understanding of the universe today. And what we're going to do is start with the ancient Greeks. Although there was astronomy done before the ancient Greeks were really the first society of people to make a coordinated effort to try to understand the world around us. So we'll start with the ancient Greeks, and we will finish this section by getting up to the point of talking about Isaac Newton, because Isaac Newton was a very, very important contributor to our understanding of the universe around us, and it's really work that was done that has not been rivaled ever since. So the cast of characters include the people that you see here on the screen, and we'll talk about each of them individually and discuss what their contributions were. Now, let's start with a quote, and one of my favorite quotes in astronomy comes from one of the people that we're going to talk about, and his name was Johannes Kepler. And we will eventually get to what Kepler's contributions to astronomy were. But for now, we're going to start with his quote because he's referring to something that's very important that we need to think about as we go through our understanding of how the basic ideas came about and how the ancient societies of the Earth really didn't understand many things about our universe, but had to start somewhere. He says in his quote, "It is therefore impossible that reason, not previously instructed, should imagine anything other than that the Earth is a kind of a vast house, with the vault of the sky placed on top of it. It is motionless, and within it, the sun being so small, passes from one region to another, like a bird wandering through the air." Now, Kepler is saying this about 400 years ago, and to you and I, this sounds like a long time ago, somebody who lived 400 years ago. But Kepler is referring to the ancient Greeks, who, to him, 400 years ago, these people lived almost 2,000 years ago. So he's referring to how the ancient Greeks were trying to figure things out for the first time. You'll notice in the quote, it says, and it starts off by saying that it is therefore impossible that reason not previously instructed. Now, what that means, reason not previously instructed, means that they did not have the luxury of having somebody who had already figured out some of these basic ideas to tell them whether they were on the right track or they were going down the wrong path. So without the luxury of having somebody to tell you whether you're doing something right or doing something wrong, what Kepler is saying is, without that luxury, they were going to make a lot of mistakes. And the three big mistakes that he's referring to in this quote, the first one is, by referring to the Earth as a vast house, he's talking about how the ancient Greeks believed that the Earth did not move, like a house is sort of a permanent structure, and it is something we don't often think of as something that moves. The vault of the sky placed on top of the Earth, in this statement, he's referring to the celestial sphere. And if you remember from a previous segment, we talked at length about how the ancient Greeks believed in this celestial sphere that surrounded the earth that all of the stars of the universe were attached to. So he's saying that they believed in the celestial sphere even though we know that there is no such thing. And he refers to how the ancient Greeks believed that the sun was very small, passing from one region to another like a bird wandering through the air. What he's referring to is how the ancient Greeks believed that it was the sun that went around the earth, not the other way around. Today we understand that the earth orbits around the sun, but this is something we had to figure out, and the ancient Greeks originally got that backwards. They believed it was the sun orbiting around the earth. So in essence, when we take this entire quote, what he's saying is that mistakes were made, believing things that were incorrect, but the ancient Greeks did not have the luxury of having somebody to tell them whether they were doing something right in figuring out these things or whether they were heading down the wrong path. And today, we do have the luxury of all these people we're about to talk about who have figured out these things before us. Now, the next quote I want to show you comes from Carl Sagan. And it's a brief quote, but he says an important thing. He says, "Our ancestors were eager to understand the world, but had not quite stumbled upon the method." And as you can imagine, he's referring to the scientific method. And what he's saying by this statement is that our ancestors were intelligent people, they were inquisitive, they were capable folks, but they just didn't have the scientific method to tell them whether they were doing something right or something wrong. And let me remind you, as we've seen in a previous segment, the scientific method, or if you recall, we refer to it as the scientific mantra, is one where we only adopt explanations to be the ones that are correct when they're supported by all of the evidence. And again, putting it in a more scientific way, any theory is considered to be correct only if it is supported by all of the measurable facts. This is how we live today, this is how we do science today, but the ancient Greeks did not follow this principle. To the ancient Greeks, if an explanation sounded good, if it seemed reasonable, then it was considered to be correct. There was no effort to do testing, there was no effort to gather evidence, there was no effort to try to make it so that the universe could be described in reproducible ways of experimentation, which is something we do today, which is again the bedrock of science. So to put all this together, the ancient Greeks were very curious. They wanted to know about the universe around them, but they didn't have the method of science to guide them down the path of figuring out what is right and, of course, steering them away from what is wrong. Now, to demonstrate this, let me show you one particular idea that sounds very simple, sounds almost trivial, but let me show you how complicated it is to figure this out. So let's start with a question. In previous segments of Astronomy 100, we've talked at length about how important it is to understand that the Earth rotates. We've talked about the rotation of the Earth when it comes to the rising and setting of the sun and the moon and the stars, what we called diurnal motion. We've talked about the rotation of the Earth when it comes to phases of the moon and how we see them from different times of the day versus where the moon is in its orbit. Many different things rely on the fact that the Earth rotates. But the one thing that I haven't done so far this semester, is to describe to you how we know for sure that the Earth rotates. It's just something we take for granted. Somebody, somewhere along the way, figured this out, and we have simply accepted this fact ever since. But let me show you how very complicated it is to prove something so simple, and how the ancient Greeks were really never going to figure this out. So here's the first idea. The Greeks were well aware of two important things about the Earth, and we'll talk about these in future segments. But they understood that the Earth was round, was a spherical body, and they also understood that the Earth had a particular size to it, and they had already figured out what the size of the Earth is. So let me kind of walk you through this. If you were to travel over the equator of the Earth and go all the way around the Earth and come back to where you took off, let's say in an airplane, you'll travel a distance of about 24,000 miles. That's the circumference of the Earth. Now, the Earth has to turn on its axis and turn all the way around one time in 24 hours. And so if you do the math on that, to turn 24,000 miles in 24 hours, that means at the equator of the Earth is turning at about 1,000 miles per hour. But the ancient Greeks knew that when you go outside, no matter where you happen to live on Earth, you don't feel the effects of this 1,000-mile-an-hour movement if the Earth really was rotating. So an example is we don't feel the sensation of movement. And if the Earth is turning at 1,000 miles per hour at the equator, you can imagine that there should be a tremendous breeze in your face. The ancient Greeks sort of came up with the idea that when you're moving along the surface of the Earth, let's say back in those days in a chariot, if you were moving at 20 miles per hour, you had a 20-mile-an-hour breeze in your face. But at the equator of the Earth, there is no 1,000-mile-per-hour breeze in your face. You could even make the adjustment to where San Diego's latitude is. If we adjust it to the circumference of the Earth at San Diego's latitude, the Earth is turning at about 845 miles per hour at the latitude of San Diego. And clearly when you go outside, you're not feeling an 845-mile-an-hour breeze in your face. So the ancient Greeks knew that there was no sensation of movement, at least related to any sort of a breeze in your face or feeling the movement of the Earth. So to them, that meant maybe the Earth is not moving. Here are a few other basic ideas they came up with as well. One of the things they came up with is, to them, birds should have trouble flying from one branch to another, or in this case, a hummingbird going from one flower to the next, if they're constantly trying to land on or connect with something that is constantly moving. The idea is that if an object is moving and you're trying to go from one place to another on that moving body, it should be quite challenging. And obviously birds have no trouble whatsoever when it comes to this. So therefore, the ancient Greeks thought maybe the Earth is not turning. Another idea they came up with is, if you were to throw something in the air, such as in this picture of a child throwing a ball in the air, the object shouldn't go straight up and come straight down if the Earth is moving. So an example is, if the Earth was a moving body and we had the ability to throw something up in the air, the object would go up in the air, but in the 1 or 2 seconds that it takes for the object to go up and come back down, I'm now in a slightly different place and the object lands where I was 2 seconds ago if the Earth is a physically moving body. But it's quite obvious you can throw something up in the air and it can come straight down and we have no trouble whatsoever. So to the ancient Greeks, when you put all of these things together, they could not convince themselves that the Earth was a moving body. So they made what would turn out to be a terrible mistake looking back, and that is they came to the conclusion that the Earth was not moving, not spinning on its axis, nor moving in its orbit. And so if you come to this conclusion and make it part of the foundation of what you hope to figure out about the rest of the universe, working with this idea that the Earth is not a moving body, it would then eventually send the ancient Greeks down a very, very wrong path that would take many, many years to fix. To prove that the Earth is actually a moving body sounds like it should be trivial today to be able to do, but there is no way for us to just show you that the Earth is a moving body in a very simplistic way. We have to go to great lengths to actually demonstrate that to you. So what we'll do is in the next segment, I'll show you just how we know that the Earth is truly a moving body and how the ancient Greeks, starting off with this confusing and incorrect notion of the Earth standing still, would then launch us down the wrong path. That would take about 2,000 years for us to eventually fix. So we're just about out of time, and I hope you join me next time where we'll go through the next steps. Thanks.